we're going to do is we're going to do curve sketching, but using not an equation, but a graph to help us sketch the next graph. So here we've got the diagram of f of x. And what we're going to do to help us sketch the graphs of f prime of x and of f double prime of x is use our number lines that we would normally do. So for example, we're going to have our number line for f double prime of x, and we're going to have, we'll do it in green, or I wanted to do, sorry, f prime of x in blue, f double prime of x in green. And we're imagining we're already done graphing. If we're already done graphing, I hope you can see from our graph that we have a local minimum right there. What would that tell us about the first derivative? The first derivative would have, at that point, 0. Does that make sense? That the first derivative, which I'm graphing in blue, I know that I would have this point. We could actually, because it's a parabola, know that it's halfway in between here. Does this make sense that this would be at 2? And that your first derivative would be 0 at 2. You also know that the original function is going down and then up. From our first derivative, if it's going down, what number did we get in our first derivative? A negative. If it was going up, what number did we have in our first derivative? A positive. So my first derivative graph, after 2 has to be positive, before 2 has to be negative. And there's a graph of a sketch of what f prime of x could look like. The second derivative. Are there any places that we have inflection points on here? Does it change from concave up to concave down anywhere? No. Can you see that it is always concave up? If it is always concave up, the second derivative always has to be positive. So a possibility for my second derivative is this straight line. Because also, my second derivative is the derivative of my first derivative. And can you see that this is a straight line with a positive slope? And if that line was 3x, can you see that its derivative would be a constant, always equal to 3? So a couple of things we're going to use with these graphing questions. We're going to use our number lines that we have for f prime and f double prime to figure out where things are positive and negative to help us graph. We're also going to use a little bit of derivatives in the sense that this graph, even though I don't know its equation, is an x squared graph. What's the derivative of an x squared graph? A 2x. A 2x graph would be a line. The derivative of a parabola is a line. So my blue line makes sense based on starting with a parabola. Then the derivative of a line, if you had y equals 2x, the derivative of that would just be 2. That makes sense that that would be horizontal. Here's example 1. This one was starting with the regular graph and moving through the derivative graphs. Example 2, again, we're starting with the regular graph and finding our derivative graphs. So off to the side here, I'm going to draw my number line for f prime of x. And I'm going to draw my number line for f double prime of x. Can you see on our original graph we have a maximum here and a minimum there? On our f prime of graph, we would have 0 there. And we'll assume this is going by ones, and 4 there. Do you see that our graph is going up, then down, then up? Which means that our graph, this has to be positive to go up, this has to be negative to go down, this has to be positive to go up. We now have enough information to draw our first derivative. We would know at these two black points that our derivative is 0. We know that between 0 and 4, it's negative, and in the other directions, it's positive. Now I just drew a parabola. Does a parabola seem like the right derivative of an x cubed graph? Yes. Now on our second derivative, can you see that we change from concave up to concave down about there? So I could put on my second derivative 2, and I know this part is concave down, this part is concave up, negative, positive. And because I have an inflection point at 2, I know my second derivative is equal to 0 at 2. And it needs to be positive here, negative here. Does it make sense that the derivative of a parabola would be a straight line? So because we know the shapes and we recognize the kind of graphs, it does give us a hint for what the graphs are going to look like. What's not accurate here is I'm guessing my slope. I'm guessing the slope of that line. I don't know exactly what it is. I'm guessing my parabola, where the minimum is, could be down lower, could be wider, I don't know. Those are things that I'm just guessing at this point. Okay. Example 3. This is the derivative graph. We need to find the original graph. If this is the derivative graph, what values do I have on my number line for the derivative? All right. What values did we put on our number line for our derivative? We put the values where the derivative was equal to 0. Can we see on here that they told us that that would be negative 2, 0, and 3? Okay. So I'm going to tell you these graphs, if they hurt your brain a little bit going in from one direction to another, it's because it's complicated to think what everything stands for and understand. So on our derivative, we always put where our derivative was equal to 0. If this is our derivative graph, they told us exactly where it's equal to 0. Can you see that on this side of negative 2, my derivative is positive? So this graph is telling me positive. This section is below the x-axis, negative. This section, positive. This section, negative. And if I have those positives, negatives, that tells me my original graph goes up, then down, then up, then down. And I know that I need to have a maximum somewhere at -2, a minimum somewhere at 0, another maximum somewhere at 3, and my graph has to follow this shape. So I'm going to pick a maximum, minimum, maximum. I don't know if that's exact. It might be moved up higher, it might be moved down lower. But what the important thing is do we have our maximums, minimums, and the right shape for this graph? This looks like a -x to the 4 graph. The derivative of a -x to the 4 graph would be a -x to the 3 graph. And the black graph is a -x to the 3 graph. You know how in transformations in grade 12 you could take a graph and move it up if you wanted to by just adding 7? If you add 7 to this graph, the blue one, can you see I would just go up 7? And when I take the derivative, what's the derivative of that 7 going to be? 0. This black derivative graph is the same for this one as it would be if I moved it up 7 or if I moved it down 10. Now, don't go and say, well, I graphed it, but unfortunately it was translated 500 units below, so nothing actually showed up, Mr. JR, but you should still give me full marks. That might be pushing it a little. Okay. Next one. Here's F double prime. So what do we know? We know information from F double prime. Does that information tell us things about F prime of x? And then can we graph the original? If this is F double prime, we have this value right here. And let's call it C. That would show up there. And if this is F double prime, before C, it's negative. After C, it's positive. I'm going to draw the concave down and the concave up because that's normally what we see from our second derivative. And that's going to be important for our original function. But if we are using the second derivative to find our first derivative, I'm going to leave this for next.